Hey, hello sir. I'm making this video. This is a quick video to show you the simulation of the AX-14 with 4 pairs. It's basically the same circuit. The only difference is that I add more pairs. Instead of only having 1 pair, I have 4. And on the driver transistor, I choose this driver transistor. This one is pretty good. The MJE15032J from ON. This is a pretty good transistor. I'm going to show you where I can get that one. So right now, and let me see, it's a pretty good one. So this is a good driver transistor for this application. That is designed for use. Sorry about that. Okay, let me zoom in. Okay, designed for use as high frequency drivers in audio amplifiers. So this one is a pretty good a driver transistor for the base of those power transistors. So here's the information right here. So this is the information of this driver transistor in particular. You can see. Let me see if I got it. Yeah, I think I got it correctly. MJE15033. Yeah, that should be fine. I think I have it correctly here. Let me see. Yes, it is. No, it's not. No, it's not. I have the different one. Yep. Okay, I don't mind about that. I can fix that right away. It's okay. This thing happens. There you go. 15033J. 15033J. Let me see. Okay, 15033J. Okay, let me save this file. I made many simulation on this circuit. I think it responds really well on simulation. Right now, I have like, I can say like 300 watts. I mean, my intention is not to get a lot of power, just just to have a little bit enough, for those base nodes. So let me fix this to make it look nice, make it look pretty. Right now, I'm using a different type of power transistor. These power transistors they are really good. Let me show you. These are from ON Semiconductors. They are kind of expensive, but they are really good quality transistors. Let me find it for you right quick. I think I have on Mouser. Let me see. They are quite expensive. They are really expensive. Let me show you right quick. Okay, there you go, right here. The MJL4281 Alpha A and MJL4302 Alpha are power transistor for high power audio. Collector voltage 350 volts. Wow, that's a lot. Let me see. High say operation area 1 amp, 100 volts to a 1 second. High FT, something like that. Collector current 15 amps. It says 30 amps too, 15 amps. So it basically looks like similar to the Toshiba. Okay, now I'm going to activate the simulation so you can see that the total minute distortion is pretty decent right now. I'm not trying to get to the clipping area. I'm not pushing the amplifier to reach the clipping, because it's not going to be correct. I'm going to activate the simulation right quick. Run. You can tell that looks pretty good. I have 310 watts to 4 ohms low, and the total amount distortion is pretty low. I'm going to show you the lowest THD. I'm going to use 100 millivolts amplitude, 1 kilohertz sine wave. Let me see how low the total distortion can go. As you can see, it's 0.001%. That's pretty good. That's pretty good right there. I think it can go even lower than that. I think. Let me see. All right. I think it's. Let me try to lower that. The total amount. Okay, there you go. The total amount distortion is 0.001%. That's pretty good right there. So let's say at 700 millivolts input sine wave. Let's see. Okay. We have 387 watts. Okay, I really don't want to go to the clipping area. So let's say with maybe the feedback I changed, I forgot. No, the feedback is fine. It's the same. Resistor R11 is the same, so it should be fine. So I made this simulation because I was working with different layouts and stuff like that. I do have the, oh no, it's the same one. It's this one here. This one is with 4 pairs. If you want to, I'm going to send you this file. You want to try it out and make your your PCB with 4 pairs. Let me tweak it. Let's say share file. Let's say share file. There you go, share file. All right, there you go. So I have I think I have, let me see, two no, I was working with this one. I got 4 pairs, 2 pairs. Let me see, I think I made one that is 3 pairs the other day, but it's fine. You can modify. The only thing you gotta do is select this part here, and you just move it to the right, and then you can continue adding more pairs if you want to. You gotta keep in mind that you cannot go further than 297 millimeters, because that's the size of the paper. The paper that you're gonna etch it. You're gonna transfer the artwork. You gotta keep in mind that you cannot go beyond the 297 millimeters, because the paper A4 size is, one example, 297 millimeters by 210 millimeters. So it's not big enough to do that. So this is the size, so the A4 paper size. One example, I'm going to show you right quick. I'm going to take this project. Oh, let's get this one here. I'm going to select everything, copy, and I'm going to paste it here. You can tell you can still add in more pairs if you want to, but I don't think it's necessary. I mean, with 4 pairs you should have a really good amplifier with only 4 pairs. 2 more additional pairs can be added too, but I think that's too much right now. Everything is fine here. These transistors, they don't need heat sink, but you can actually place your heat sink if you want to. And these transistors here, I think they need to be coupled thermally. These 2 transistors that are here, Q1 and Q2, they need to be coupled together. They need to couple a bit thermally to match them. So alright, that's it. I just wanted to make a quick video about it. So I'm going to send you the files so you can simulate it. So far with 4 pairs it's pretty good. One important note is that the voltage is 65 volt DC. So I think 65 volt DC is good enough. It's good enough for this circuit. But adding more pairs probably will help to dissipate that heat from all those 4. Let me see the power dissipation on this transistor. I forgot to read that. Let me see. The power dissipation is, let me see. Okay, 230 watts power dissipation. So wow, that's pretty good. All right, that's it, sir. I hope you like this this video and the files. And what I do, I just try to share my the small knowledge that I have, because I'm not expert like other guys on the forum, but I always try to do my best. All right, have a good day, sir.